Welcome. This is R Premananda, Assistant Professor, Government Engineering College, Averi. Okay. Assistant Professor, Government Engineering College, Averi. Okay. Now again with a continued lecture of Shannon's encoding algorithm. Here I brought up with another problem. The problem statement says that you are given a 4 messages x1, x2, x3 and x4 with respect to probability 0.1, 0.2, 0.3 and 0.4. For given this symbol and respect to probability, we have to devise a code with prefix property. This prefix property is nothing but a Shannon's fano coding algorithm for these messages and draw the code tree. Code tree has to be drawn. After that, second sub question says that calculate code efficiency and the code redundancy. And the third sub question, calculate the probabilities of zeros and ones in the code. We have to solve. Okay. First we will arrange that. See, as per the Shannon's fano encoding algorithm, the symbol should be arranged in the non-decreasing order. The symbol should be arranged in the non-decreasing order. So x4 comes first. x4 comes first. And their probability is 0.4. Similarly, x3, its probability 0.3, x2, its probability 0.1, x2 0.2, x1, its probability 0.1. See, this could be separated. Okay, this could be separated, and the previous itself said that there is no change in separating. The result will going to be the same. So I'll make this one block and this entire and another block. Okay, and I will give the code. This is for the code bit 1 and the remaining the bit 0. The upper block further splitting is not possible. So that we'll go for the lower block, that is 0.3, 0.2, 0.1. So I'll have this separate block and this as the separate. And name that for upper one it's 1, for the bottom it should be 0. Similarly, the 0.3 is further splitting is not takes place. Okay, so that this is the 0.3, 0.2 and this is the 0.1. Okay, we'll have the block. So for upper one, we'll be with 1 and 0. Now I'll write the table for this one. Okay, table where symbol or messages, symbol or you can call message, the probability and their code and their length. Okay. Here symbol that is x4, x3, x2 and this is x1. Their probability 0.4, 0.3, 0.2 and 0.1. And their code for x4 it is 1 and for x3 is 0.01, 001, 000. With this, the length of the code x4 is 1, 2, 3, 4 respectively. This is the solution of the sub question 1. We have formed the tabular column, we have devised the code with the prefix property. And next it says that to find the code tree, I'll call this the S. Okay. And with the probability 1, I call it the S1. Okay. 0 with probability 1, this is S2. 0 with probability 1, you will get S3. 0, this is S4. This is how the tree diagram, this is code tree. Code tree for example 2. The second example, the previous what I did found the first example. This is table 1, code table for example 2. Code table for example 2. Okay, I have found the first sub question. Next, you have to find the efficiency and the redundancy. Efficiency and the redundancy we are supposed to find. Okay. Okay. We have got the formula to find the efficiency and the redundancy. We have got the formula. Okay. First, you have to find the average length. Average length. That is L is equal to summation I is equal to 1 to 4 elements. So the Pi into Li, that is 0.4 into 1 plus 0.3 into 2 plus 0.2 into 2 plus 0.1 into 3. Point into 4. 0.2 into 3. Okay. On solving this, we get the average length of 1.9 minutes per message symbol. Okay. Now to find entropy, we have to find the entropy. That is H of S is equal to summation I is equal to 1 to 4 Pi log 1 upon Pi. Okay. On solving this, we will get this as 0.4 log 1 upon 0.4 plus 0.3 log 1 upon 0.3 plus 0.2 log 1 upon 0.2 plus 0.1 log 1 upon 0.1. And the entropy you are going to get, that is H of S, the entropy. Answer for this is 1.846. 1.846. This is bits per message symbol. Okay. Now the efficiency. Efficiency is equal to H of S divided by L. H of S is 1.846 and L is 1.98. L is 1.9. L is 1.9. With this, the efficiency is 97%. 97.15%, and the redundancy, that is equal to 1 minus the efficiency, is 2.85%. 2.85%. Okay. And next we have to find the probabilities of zeros and ones. Sub question 3. We have got the formula to find the probability of 0. We have to take the average length 1 by L, summation I is equal to 1 to 4, number of zeros in code 1, number of zeros in code 1, number of zeros in code for xi multiplied by their probabilities pi. Their probabilities pi. Okay. So look into here. Okay. Number of zeros in the first code is 0, whereas in the second code is 1, third code is 2, and the fourth code is 3. 3 zeros. Okay. I'll write this in the diagram, this equation. So what is 1 by 9? Okay. Number of zeros in the first code, that is 0 into their probability is 0.0 plus, and number of zeros in this 0.3, number of zeros in 0.3 is 1. So 1 into 0.3 plus 2 into 0.2, 2 into 0.2 plus 3 into 0.1. See, in the 0.4 probability, 0 ones are there. 0.3 probability, 1 is there, 1 0 is there. In 0.2 probability, 2 0 is there. In 0.1 probability, 3 zeros are there. So that writing that and finishing the equation, solving, we will get it as 0.5263. This is P of 0 is 0.5263. Similarly, P of 1 by average length, P of 1 by average length, summation of I is equal to 1 to 4, number of ones. There we was having the 0. Now it is number of ones in code. Xi multiplied by their probability Pi. Okay. 1 by L is 0.9. So in 0.4 first code we have got 1. First code we have got the 1. 0.4 in first code in 0.4 we got the only 1 ones. Okay. And in the second code, that is with 0.3, there also 1. And in the 0.2 code, it is 1. Whereas in 0.1, it is 0. So, answer of this is answer of this is 0.4737. 0.4737. This is the probability of ones is 0.4737, whereas the probability of 0 is 0.5263. I'll come up with some more problems in the next session. Thank you, one and all.